use algebra to solve and determine the general solution. This is a calculator one. So first of all, now I notice I have a cos squared and also a cos. That gives me a quadratic equation. To solve a quadratic equation, I can either factor or use my quadratic formula, but before I can do any of that, I need to make one side equal to 0. So I move the 3 cos squared x to the left side. I move the positive 1 to the left side. And now I have one side equal to 0. Battery's getting so bad, didn't even last for one period. Okay. We have to check if we can factor this. If it was factorable, okay? If it was factorable, and it's not, but let's say you try to factor it. If you tried to factor it, I hope you could see that the only thing that would give you 3 cos squared with nice numbers is 3 cos x and cos x. And the only thing that would give you 1 with nice numbers is 1 and 1. And the outside and the inside would have a 3 cos x and a 1 cos x. Does that ever make a 1 cos x? No. So it doesn't take very long to find out that this one cannot be factored. So we would take out our formula sheet. We would take out our quadratic formula. Right? Our quadratic formula says x equals negative b plus or minus b squared minus 4ac over 2a. But we don't have x squared, we have cos squared. So for us, this means we would have cos x equals negative 1 plus or minus 1 squared minus 4 times a times c divided by 2a. And with the quadratic formula, you'll always get 2 answers because of that plus or minus. You'll get 1, and we can simplify it with the plus sign. And this will be 1 plus 12, 13 over 2. And you'll get 1 with the minus sign. And this question's in radians. So I'm going to change my calculator back to radians right away. I'm going to type this into my calculator just to see what it's equal to. So negative 1 plus the square root of 13 divided by 2. And 1 with the minus sign. Minus this part here?
No, below that.
Right here?
Yeah,
2 times 3. Yes, thank you for noticing that. My a value is 3, so this should be over. Yes. That'll change. That'll change this to a 6 on the bottom and a 6 on the bottom. So let's type that in again. Yeah, this will be 0.434. And with the minus sign, or subtract sign, it'll be now, if we had got an answer, like before when I made a mistake and I got that answer above 1, that would have meant there would be no solutions because you can never have the adjacent bigger than hypotenuse. So for sine and cos, If you ever simplify it and get an answer bigger than 1, then there would be no solutions. But since both of these answers are between 0 and 1, we can find a reference angle and solve. So we'll do the positive one first. So I go cos inverse. I get a reference angle of 1.12. Cos is positive in quadrant 1. And give answers to the nearest hundred. So in quadrant 1, it would be 1.12. And cos is also positive in quadrant 4. 5.16. We do the same thing over here. We have to find a reference angle, so we go cos inverse of the positive answer there. We get 0.6957, and cos is negative this time, so it's going to be in quadrant 2 and quadrant 3. So our quadrant 2 answer, we would do pi minus our reference angle and get 2.45, and pi plus our reference angle, 3.84. If your decimal answers are different, the only time that in pre-calculus that you round is when you write your final answer. So for my reference angle, when I write the dot, 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 that's telling you that I'm keeping all of those decimal places for all of my calculations, and I'm only rounding my answers when I get to the end for my final answer. Having a rounding error is always a half mark deduction on a quiz or a test. So we don't round until our final answer. So here we have, okay, let's make a note. Where did we get? These are the solutions between 0 and 2 pi. And this is where we go back and read the question and hope that they didn't ask for a different domain. Am I going to get disappointed? Yes? Oh, no. Between negative pi and pi. So we need, right, their domain that they asked for was from negative pi to pi. So we have to think in the positive direction, this is 0 to pi, and in the negative direction, from 0 to negative pi. We're going to do a label here. This one was quadrant 1, this one was quadrant 4, this was quadrant 2, this was quadrant 3. Which answers do we have to change? We're going to have to change this one in quadrant 4 and this one in quadrant 3. So our solutions will be x equals. We can keep the 1.12. We can keep the 2.45. The 5.16 will be negative 1.12 because it has the same reference angle and it's in quadrant 4. The 3.84 will be negative 2.45 because it has the same reference angle, 2 quadrants back, so it would match up with the 2 quadrants forward. So these would be the solutions between negative pi and pi. And finally, in part B, it asks for the general solution. And for the general solution, we would go x equals, we'd write all of our answers. And for me personally, I like to use the ones between 0 and 2 pi, so I would use pi 1.12, 5.16, 2.45, and 3.84. Add 2k pi to each of those. where k is an integer. Circle questions 12, 13, and 14.